Welcome to GatePro. In today's lecture we will be dealing with linear algebra for Gate. So let us discuss about coefficient and augmented. Matrix. Let us consider an equation a1x plus b1y plus c1z is equal to d1. Similarly, a2x plus a2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. So in this linear equations, let a1 b1 c1, a2 b2 c2, a3 b3 c3, d1 d2 d3 be coefficients. So if a matrix A is consisting of the coefficients a1 b1 c1, a2 b2 c2, a3 b3 c3, then the augmented matrix K is equal to a1 a2 a3 b1 b2 b3 c1 c2 c3, also d1 d2 d3. So this is the coefficient matrix, whereas this is the augmented matrix. So now that we know what a coefficient matrix and an augmented matrix is, let us move on to what an eigenvalue is and what an eigenvector is. So in order to understand the eigenvalue and eigenvector, let us consider an example. Let's say there is a matrix A consisting of coefficients aij, and let it be an n cross n matrix. Then the matrix A minus lambda I is called the characteristic matrix. Characteristic matrix of A. Now where I is an identity matrix. Now the determinant of A minus lambda I is called the characteristic polynomial of A. Again, the equation determinant of A minus lambda I is equal to 0 is the characteristic equation of A, and the roots from this equation are the eigenvalues. So the problem of finding the eigenvalues of a matrix is called eigenvalue problem. If lambda is a characteristic root or eigenvalues of an n cross n matrix A, then a non-zero vector x such that A of x is equal to lambda x is called the characteristic vector. Characteristic vector or the eigen vector. It is called as eigenvector of A corresponding to the characteristic root root lambda. The set of eigenvalues of A is called the spectrum of A. Hope you understood what an eigenvalue is and an eigenvector is.